You know that feeling when you're staring at an equation and the one variable you need to find is stuck way up in an exponent? It feels kind of locked away, right? Well, today we're going to learn how to pick that lock. We're going to master a super powerful tool, the power property of logarithms. Let's dive in.
So here's the game plan. First, we'll look at that classic trapped exponent problem. Then, I'll introduce you to the key, the power property of logarithms. After that, we'll see it in action, talk about a few common mistakes to watch out for, and finally, we'll see why this one property is such a big deal in the real world.
All right, let's start with the problem that brings us all here. It's a fundamental challenge in algebra, you know? When your variable is way up high as an exponent, how in the world do you get it down? Our usual algebraic tricks, well, they just don't work.
Okay, take a look at this equation. 3 to the power of x equals 50. Now, we can guess, right? We know 3 cubed is 27, and 3 to the 4th is 81. So x has to be somewhere between 3 and 4. But how do we get the exact value? We can't divide by 3, we can't take the xth root. Our variable x is completely trapped, and our normal tools can't set it free.
This is where logarithms ride in to save the day. Specifically, one of their 3 main properties acts like the perfect key, designed specifically to unlock that trapped exponent and set it free.
And here it is. This is the power property of logarithms. Formally, it says that the log of a number m raised to the power of n is just n times the log of m. Now, I know that sounds a little technical when you say it out loud, but what it does is pure magic.
And here's the beautiful part. That little exponent n that was trapped up there, this property lets us just grab it and bring it right down in front of the log. It goes from being a tricky exponent to a simple multiplier. That one move, bringing it down to the main level, that's what changes everything.
Now, just to put it in context, you've probably seen the other 2 log properties, product and quotient. And they're great for handling multiplication and division inside a log. But the power property, it's special. It's the only one that lets us mess with exponents directly, turning them into something we can actually work with. Theory is one thing, but let's actually see this key unlock some doors. We're going to start with a pretty straightforward example and then build up from there. So first up, let's simplify log base 2 of 8 to the 5th power. Now, you could try to figure out what 8 to the 5th is, but why would you? Let's just use our new trick. We grab that 5 and bring it down in front. Now we have 5 times log base 2 of 8. And we know log base 2 of 8 is just 3. So our final answer is simply 5 times 3, which is 15. So much easier.
Okay, for our next example, we need to dust off a really important idea from algebra. Roots are just powers in disguise. They're fractional powers. Remembering this little fact unlocks the full potential of this property.
Let's try to expand the natural log of the square root of x. The absolute first step before you do anything else is to rewrite that square root as an exponent. So it becomes x to the 1/2 power. And now that we have an exponent, boom, the power property kicks in. The 1/2 comes down to the front, and we're left with 1/2 times the natural log of x. That's all there is to it.
Now what's really cool is that this isn't a one-way street. Just like we can bring an exponent down from the top, we can also take a number in front and send it right back up to be an exponent. And this is super handy when you want to condense a bunch of logs into just one. So to rewrite 3 times the log of x, we just do the exact reverse. We take that coefficient, the 3, and move it back up to become the exponent on the x. And just like that, we have a single clean term, the log of x cubed.
So using this property is pretty straightforward. But, there are a couple of really common traps that are super easy to fall into. Let's make sure we know how to spot them so we can sidestep them completely.
Okay, this is the big one. The power property only works when the exponent is on the argument of the log. That's the x in this case. If the exponent is on the entire log expression, like log x cubed, the property does not apply. That's a totally different thing. You have to look really closely to see where that exponent is sitting. And I'm going to say it one last time, because it's that important. Always, always convert roots into fractional exponents first. This is probably the #1 spot where people get tripped up. Just make it a habit. See a root? Change it to an exponent. Then you'll never apply the property wrong. So we've seen how it works, we know what to watch out for, but why should we really care? I mean, what does this actually do for us outside of a math class? Well, this is where it gets really powerful. I really love this metaphor. The power property lets us unwrap the unknown exponent.
It's like the variable is in a box, and this is the only tool that can open it and get to what's inside.
Think about almost any real-world question that starts with, how long until, How long until my investment doubles? How long until this radioactive material is safe? How long will it take for a city's population to reach a certain number? All of these are exponential growth or decay problems, and the power property is the essential tool you need to find the answer.
So when it comes down to it, the power property does something pretty amazing. It takes an exponential equation that looks completely unsolvable, and with one simple move, it transforms it into basic algebra. It's the bridge that gets us from a really complex problem to a simple, elegant solution.
And that's a wrap on the power property of logarithms. You officially have the key to a whole new class of problems in math and science. So, the only question left is, what exponential problem are you gonna unlock first?